The subject matter that I'm going to touch upon is frequency distribution. And it's a relatively simple concept, but there are different components to it, so I'm just going to tackle them one at a time. First of all, frequency distribution is a grouping of data into mutually exclusive categories, showing the number of observations for each class. So now that I explained it, we're going to do some visuals as to how we would attack a frequency distribution problem. And we're going to start off with a random group of numbers, and I'm going to list them right here. For those of you who are interested as to what these numbers represent the various ages of interns for Google's internship program. Okay. Alright, these are the different ages for the interns. As you can see, some people are young, some people are older. 18, 22, 30, 35, and then finally 31, 30, 19, and 20. So this is the different ages, and the total number that we have here is 20. And that 20 is going to represent the number of data that we have. Okay? And the first thing that we like to do in a frequency distribution problem is identify how many numbers that we have, because the frequencies are going to be equal to the number of data that we have. And the first step is to organize them into categories. So I'm going to prepare a table here so that we can organize them into categories. However, we don't know how many categories that we're going to use. So in order to find out how many categories we can organize this into, we use a formula called the number of classes formula. And the number of classes formula looks a little bit like this: 2 to the power of k greater than n. So our objective is to find a number to the power of 2 that is greater than the number of data that we have, which is 20. And we can start off using 1. 2 to the power of 1 is not greater than 20, so we need to find the right number to allocate to this. And let's skip down to 2 to the power of 3. That is still not greater than 20 because 2 to the power of 3 is 8. We can try 2 to the power of 4, which is still not greater than 20 because it equals 16, so it's not greater than 20. These do not exceed 20. But 2 to the power of 5 seems to be our winner because 2 to the power of 5 equals 32, and 32 is greater than 20. So our k value is 5, and this k value is the number that tells us the number of categories that we are going to organize this group into. So it's going to be 5 categories. So we're going to list them: 1, 2, 3, 4, 5. Make a little line for each. And now that we know how many categories we have, now we need to organize them into intervals. And intervals is a range between certain numbers. For example, 18 to 21, 21 to 24, 24 to 27. From this small example, you can notice that these are intervals of 3 from 18 to 21, and they remain consistent. So this is the type of organization we want to emulate here using this data. Okay, so I'm going to do that real quick. In order to know what our interval will be, we use a formula that I'm going to write down here. now that we understand the concept of organizing them into classes. And the formula for intervals is I for interval greater than or equal to the highest number in our set of numbers, subtracting the lowest number from the highest number, and dividing that by the number of classes that we have, which is 5. Okay, so let's take a second to identify the highest number and the lowest number. And it looks like the highest number is going to be 38, and the lowest number in this data group is going to be 18. So when we apply that to the formula, we are going to subtract 18 from 38 and divide that by 5. And what we get is, well, 38 minus 18 turns out to be 20 divided by 5. And our answer is 4. So the intervals is going to be greater than or equal to 4. So what this means is the separation that we're between the numbers is going to be either greater than or equal to 4. We don't want it to be less than, because that will mess up our data. So starting with the lowest number, we are going to organize them into 4: 18, 19, 20, 21, and 22. We're going to do it from 18 to 22. And I will explain to you how that's going to work. After that, you add another 4, that will be 22 to 26. And then we'll do 26 to 30, 30 to 34, and 34 to 38. The interesting thing about this is that it's continuous. It does not stop from 18 to 38. However, for this set of intervals, we are either going to include 22 here and then exclude it here, or we are going to exclude 22 here and include 22 here. Whichever way you do it, you need to remain consistent. And for this, we're going to exclude 22 here and include them here. Then we're going to exclude 26 for this and include it here. And now we're going to see how frequently these numbers appear inside this interval. So now, before we go any further, there's one critical mistake that we'd like to point out, and this is going to be a good learning curve. So the way this is organized now, we need to include 18 and 38 in our frequency table because those two numbers are included in our data. And if we include 18 to 22 here, we're going to be leaving 38 out. So our objective now is to widen out the interval, which is possible because an interval can be greater than or equal to this number. The intervals for our categories. So we're going to increase it to 5 and change these numbers up just a little bit to where the interval space between the numbers are 5 instead of 4. Okay? Alright. So instead of it being from 18 to 22, we're going to do it from 17 to 22, 22 to 27, 27 to 32, 32 to 37, and 37 to 42. Now that we have these numbers, we're going to, proceed to do the same thing. How many times does the numbers between 17 to 22 appear in this data? 17 to 22 still happens to appear 8 times. 22 to 27 appears in this data 4 times. 27 to 32 appears 5 times. 32 to 37 appears twice. and 37 to 42 appears once. Now we have the frequencies right here. And notice how the frequencies total up to be 20, which also equals our n. Because however many times these numbers in this interval appear here, for each class should add up to 20. So we now have 20, and in order to get the percentages, we're going to extend this table, and we're going to divide the frequency divided by the total frequency. And that is going to be 8 divided by 20, 4 divided by 20, 5 divided by 20, 2 divided by 20, and 1 divided by 20. Then we're going to list the percentages over here. And 8 divided by 20 is 0.40. 4 divided by 20 is 0.20. 5 divided by 20 is 0.25. 2 divided by 20 is 0.2. I'm sorry, 0.10. And 1 divided by 20 is 0.05. When we convert these to percentages, I'm now going to erase this. For each of our classes, we have 40%, 20%, 25%, 10%, and 5%. And these are the frequencies associated with our 8 class intervals. And after we have these frequencies and the percentages associated with it, we can give a graphic representation through what we call a pie chart. And for those intervals, we can show them through the pie chart. And how to construct a pie chart is very simple. We can just associate the percentages each. 40% would look a little something like this. This would be 40%, and this 40% will represent the intervals from ages 17 to 22. And once you allocate a certain percentage for each, 25, 20, 25, 5, and 10, you can associate each one with the age, and you will have your pie chart.